Section 2.5 is on page 131. Talks about inequalities. The inequality symbols are, there's 4 of them. Less than, greater than, less than or equal, greater than or equal. And normally, the smaller is where you're pointing to, and the opening is toward the larger. You start reading an inequality symbol from where the variable is. So if I write this, you read x is less than 5. X is less than 5. If I put that in, x is less than or equal. So that's what this adds, meaning included. Linear inequalities, we have a few types of inequalities. One of them is linear. We operate on the inequality symbols like an equal, identically, except whenever we multiply or divide by a negative, whenever you multiply or divide by a negative number, you need to switch the symbol. Now the inequality symbols, here they are. Graphically, you would fill a circle. Some books use brackets on the graphs as well. I'd rather stick with this. And if it's not included, you would use an open circle. Now, interval notation, you would use brackets whenever you have included and parentheses whenever you don't have an equal. And the endpoints, if you see equals, that means including the endpoint, and if you don't see equal, that means excluded. I'm just going to take this out because they're going to clutter the graphs. Here, let's keep it simple. Now, one thing about interval notation, you look at the graphical solution and you read the graphical solution left to right. You never include infinities. And let me start with this. It says write the solution set of each inequality using interval notation. I'm going to graph it. So I'm going to say graph the solution set. Just for practice, make sure we're all seeing this. So I treat this like I would treat an equal. I would eliminate parentheses first. Distribute that in. That's 6x minus 30. It would be wise to move the smaller to the larger. So I'm going to move the 5x to the right. Since I didn't multiply or divide, that symbol remains. And 5x plus 6x is 11x minus 30. Move the 30 over, meaning add 30 to both sides. 33 is greater than or equal to 11x. And if you divide by 11, you get x to be less than or equal to 3. I'm going to shift this solution to the left just a bit. And the graphical solution on a number line, you don't need to label 0, 1, 2, 3. You just need to label the point in the solution, which is 3. It is included. And if you read this, x is less than. Less than, you always shade to the left. Greater than, you shade to the right. Interval notation, if you look at the graphical solution, this graph runs all the way to negative infinity, up to 3. This is included. Even though this runs all the way to negative infinity, we never include infinities. And that's my solution set right there. If I look at, I added 2 more problems because we don't have enough practice in the book. Negative 2x, 3 over 10, less than 1 over 10, plus 6 over 10x. I see a fraction. LCD comes to mind. Don't forget this is over 1. The LCD is at 10. So this is missing a 10. Now that they all have it, we ignore that. Negative 10 times negative 2 is negative 20x. Minus 3 is less than 1 plus 6x. I should move the 20 to the right, but for practice, just for practice purposes, I'm going to move the 6 to the right. That makes it negative 26x minus 3 is less than 1. Add 4 to both sides. Add 3 to both sides. That makes it a 4. And if I divide by negative 26, there it is. We have just applied the rule. We divided by a negative number, which means I need to switch the symbol. X would be greater than negative 2, I'm sorry, 26. If I reduce it by 2, that is negative 2 divided by 13. There's my algebraic solution. My graphical solution, I would put a number line. And on the number line, I just need to label negative 2 over 13, which is close, between 0 and negative 1. It's not included, so that's an open circle. X is greater than, you would shade to the right. So if I read the graph left to right, the first point I come across is 2 over 13, running all the way to infinity. Since that's not included, I use parentheses, and we never include infinities. Interval notation, graphical solution, graphical solution, and algebraic solution. And normally those go hand in hand. That last example I have, also a fraction. I look for LCD, in this case it's a 6. Multiply this by 6 top and bottom, this by 2 top and bottom, and this by 6 top and bottom, and you treat it like an equal. Since they all have the same denominator, you ignore the denominator now. Basically, you multiply both sides by 6. This is x, you didn't multiply it by anything. Negative 6 times 8 times 3 is 18. 2 times 2 is 4. And 6 times x is 6x, and here it is. Add 6x to both sides, that's 7x. Add 18 to both sides, that is 22. And divide by 7, x is greater than 22 over 7. That's algebraic solution. A graphical solution, I'll take a number line. And I only need to mark 22 over 7. Since it's the only number in question, that's all I need, which is about, 3 and 1 over 7. That's not included. X is greater than, you shade to the right. And interval notation, if you read the graph left to right, that would be 22 over 7, comma, and it's going to run all the way to infinity. Not included. We never include infinities. Algebraic solution, graphical solution, interval notation. Now, we have two types of sets. We have the intersection of two sets, A and B, denoted by A intersect B, would be the set of all elements that belong to both sets A and B. The union of two sets, denoted by A union B, that is the set of all elements that are in the set A or in set B or in both. Basically, whatever is there, you accept. I didn't mention this is on page 146 in our book, number 2, A and B I made up. So the next set of problems, it says, in exercise 7 to 34, write the solution set of each inequality. Use interval notation. If there's no solution, write the empty set or no solution. The empty set is really just two set of parentheses. Well, I solved each of those individually. This is already solved. That's because, when introducing this, we want to give you a simple problem to do graphically. This says x is greater than negative 4. Let's say negative 4 is right there, included. X is greater than, you would shade to the right. So basically right there. And if I look at x is less than 9, negative 9, so this is negative 9, not included. You shade to the left. And for an or, any solution is accepted. If you read this left to right, negative infinity to negative 9, not included. Negative 4 to infinity, not included. Whenever you have more than one interval, 2, 3, 4, you always use union, this, or both. Number 10 is next. Well, the same deal. They kind of solved it for us. If I take the first solution, it says m is less than 5. Okay, there's 5 right there. Included. Less than is to the left. So here it is. And 0 is to the left of 5. not included, and I shade to the right because m is greater than that. And if you look at that, you'll notice that, so that graphical solution is extra, they're not asking for it, it helps. If you look at that, since it's OR and you take whatever is shaded, you notice that we shaded the entire number line. The solution would be a negative infinity all the way to infinity. Any solution will work, or all real numbers, however you want to see that. Now, if I look at number 16, I deal with those individually. I start with the first. Well, I'm gonna subtract 5 from both sides. Negative 3x is less than or equal to negative 7 minus 5, that would be a negative 12. And whenever I divide by a negative, I will have to switch the inequality symbol. And that would mean x is greater than or equal to 4. I got the first solution. Let me go for the second. Here, I move the 8 over, and this reads x is less than or equal. Negative 8 minus 1 is a negative 9. There it is. Again, graphical solution is not part of this, but I'm adding that just to make it simpler. X is greater than 4. 4 is right there. Included. Greater than, we shade to the right. Let's say it's right there. And x is less than negative 9, and a number line negative 9 is to the left of 4. X is less than or equal, included, and you shade to the left. And again, no harm there. It's really simple. You just write down whatever you see, and that would be, just gonna move this up, since negative infinity in the green all the way to negative 9 included, 4 to infinity, that's included as well, and union will be. That would be the solution they're looking for. Now, the next set of problems is the AND. Well, again, the first problem is pretty much worked out. It's perfect practice. The graph is not part of this. I'm adding that to it. X is greater than or equal to negative 2. There's negative 2 included. X is greater than, you would shade to the right. So that solution is right there. X is less than or equal to negative 12. Negative 12 is to the left of negative 2 on a number line, included. Less than, you shade to the left. And if it's an AND, you're looking for an overlap. You notice that there's no overlap between those, so this means feed the empty set, no solution. You could write no solution, but that's normally how it is. You could use any of those. You could write this, you could write the empty set, or you could say no solution. No harm done there. And if I take number 14, it's also worked out. So the first solution, y, so this is y is greater than negative 2. Let's say negative 2 is right there. Let me move it a bit more to the left. Negative 2 is right there. Included, y is greater than. So if I shade this with yellow, there it is. And if I take this to be the green, again read it from the variable, y is less than 3, there's 3, not included. And if I shade that with blue, you'll notice the two colors overlapping give a green. So if I really, they're not asking for the graphical solution, otherwise I would have had to graph it again, but if I look for the overlap, negative 2 happens to have both, left to right, even though that's a solution to one of those, but since it's AND, you want it to be solution to both. Running all the way to 3, and you notice 3 is only included in one of those, so that would be the solution. Another way of representing AND, provided that this expression is less than that, greater than that, and this expression is less than that at the same time. If that's the case, you would treat the double inequality like an equal as well. So how would you solve this? Normally you would add 13. Whatever you add to one of these sides, you add to both sides. So you're going to add 13 to the left and the right. 13 minus 7 is a 6, and 13 plus 15 is 28, and whenever we divide by a negative, now we have those two symbols to worry about. Negative 3, that's an x, that's negative 14, but now you're going to have to switch both symbols. That's the algebraic solution. If I put that on a number line, it's fairly simple here, no need to do much work. You put the smaller number on the bottom, of course, left, and the larger number at the right. They're both included, and you shade in between. Very simple. And the solution would be, I didn't include those. I didn't see that. Okay, so that would be negative 14, but it's included, all the way to negative 3 included.